Algebra 2, that's where we are. Today is January 8th. Happy New Year. Factoring with complex numbers. So the main thing that's happening now is we have a sum of squares that we can solve. Let's do our lesson. Starting off with some review. Difference of squares. This is something that you should have memorized because we've done 2 lessons on difference of squares. What is the formula for factoring difference of squares? I have one square and I subtract another square. This factors as what? Oh my gosh, Fiona, can you help us out? Participation cards, thank you for reminding me. Yes, how do I factor this thing? Only one person knows, and it's Eva. Is there anyone else that knows how to factor this? 2 people know. Gio knows. If you are one of those people not raising your hand, you're either really hard trying to think or you're looking back at your notes. We'll give it to Eva. There it is. Write it down in your notes. Now you know it. Thank you, Eva. You can turn in your participation card. Let's come over here, Eva. Boom, boom. 50 XP. Okay. So we know that guy. Let's go ahead and practice factoring a really big trinomial. Big trinomial because look at this. It's to the power of 66. Oh, gosh. So whenever we see a trinomial, we do advanced ninja star. Let's go ahead and set that guy up. Advanced ninja star. Whoop, whoop, and whoop. All right. So, what goes on the top? Quiet raised hand for their participation card. Fiona? 6. Yep. You can just do 6. And then on the bottom, Fiona, you can turn in your card. On the bottom, what goes on the bottom? Andrea? 7. Thank you, Andrea. You can turn in your card. Next, this is going to be a tricky question. This spot and this spot, where I just drew circles, those aren't zeros. What goes in those 2 spots? It's the same thing over and over again. Teflon? 2x. Yeah, so this is going to be a little bit difficult. It's actually 2x to the power of 33. 2x to the power of 33. And this is something that I've never really stated before, but I'm still giving you your XP and you can turn in your card. The reason that this is new, it's really just choosing this term with this number and this term. Or you can think of it as this number divided by 2. Either way, that's how you get 33. All right, then I need to find factors of 6 that add up to 7. What are those factors of 6 that add up to 7? Sego? 6 and 1. 6 and 1. Thank you. You can turn in your card. Thank you, Stego. 6 and 1, which means this now factors down to 2x to the power of 33 plus 6 and 2x to the power of 33 plus 1. Question or something that's wrong? So, ooh, I do have to simplify that, yes. Fiona and Teflon, you both log in your extra credit tracker. Boom. And you get your XP. Find teacher error. Yes, we forgot to reduce. So let's come back here. We should have reduced this fraction to x to the power of 33 over 3 and then turned it into x to the power of 33 plus 3 times 2x to the power of 33 plus 1. There's our final answer. We box it. We box it. I want the outside color to be red, inside to be nothing, and box. All right. So we know how to do all that stuff. So let's go ahead and talk about why we cannot solve sum of squares unless we add a special condition. So here's my question. Does this expression on the left equal this expression on the right? Give me thumbs up, thumbs down. Thumbs up, thumbs down. Thumbs up, thumbs down. I see 1, 2, 3, 4 thumbs up. I see 2 thumbs down. I see 1 in the middle. All right, well, let's go ahead and try it, right? We know how to FOIL this out. We know how to actually multiply x plus 2 to the power of 2. This is the nursery rhyme that I sing to Riley to make him fall asleep. It's do the do, 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 do. There's 3 things I do. Do you remember them? Who remembers them? Who still has their card that needs to turn it in? Christopher and James, I believe. And Geo? What is that little nursery rhyme? Go for it, Geo.
Boy, I just told you.
Chris, James, Geo.
Nobody's saying that.
Okay, Teflon, help us out. Square the first. Double the product. Square the last. There it is. The product of 2 times x is 2x. Double 2x to get 4x. We can multiply that out. Thank you, Teflon. That is the wrong Stephanie. There we go. That's the right Stephanie. You'll notice that there's a key difference in these two expressions. The key difference being, underline it, that 4x. There's a problem. There's a middle term. So the answer is no. They do not equal one another. No. There's a middle term that comes up. So how the heck are we going to be able to factor this guy? And the answer is you can't if you're stuck with real numbers. We've talked about I. I is, by definition, the square root of, what was it again? Do you guys remember? I is, by definition, yeah, there it is. Say it louder, Gio. Say the full thing with Mr. Sandell's statement also. I is equal to square root of -1. There it is, Gio. Go ahead and turn in your card. If we allow complex numbers, I is in the complex plane. If we allow complex numbers, then it works out. So complex numbers to the rescue. Let's try this one. Does x squared plus 4 equal x plus 2i times x minus 2i? Well, let's see what happens. So do you want to FOIL this or do you want to use that magic square rectangle thing? The square thing? Okay. So go ahead and draw your square. We have x plus 2i. We have x minus 2i. All right, let's see if we can get Chris and James in here. Chris or James, x times x is? X squared. Chris, go ahead and turn in your participation card. Thank you. And then James, this is you. 2i times x. Just sandwich them all together. Say all three of those things. 2ix or 2xi. Either way, both of them work. I'm going to say 2xi. Thank you, James. Turn in your participation card. Everyone, free game. Everyone has their cards in. Negative 2i times x. Gio.
Wait, do you say the x first or the I?
It doesn't matter.
Okay, 2xi.
2xi like that?
Negative.
Negative. There it is. Good job, Gio. I don't know what happened there. And finally, this one is tricky. Eva?
4.
It is 4. Yeah, you got it. So for those of us that weren't able to follow the step that Eva skipped, this is really negative 2i squared. But I squared is negative 1. So negative 1 times... Wait, I don't know what I'm writing here. It should be negative 4i squared. Negative 4i squared. And then I squared is negative 1. So negative 1 times negative 4 is a positive 4. That's how we got 4 there. And then when we simplify this, when we add all 4 of these together, someone help me out. When I add this term, this term, this term, this term, all 4 of them, who can simplify that for me? Andrea. X squared plus 4. And the left side is still x squared plus 4. Thank you, Andrea. So we can factor this guy by having a conjugate pair with complex numbers. So I want all of us to go back to this line and look why this works. X plus 2, x minus 2, but with an I. If you add i's in it, then it turns into a plus sign. Plus 2 minus 2. Well, I mean, I squared is a negative, but by having these i's in here, we can get this to a plus. Before, up here, it was always a minus. With a plus and a minus, it was always a minus. Over here, we had a plus and a minus, a conjugate pair, which should have been a minus, but because we added in this imaginary unit, now it's a plus. All right, so here is your sum of squares formula. In fact, I think someone might be able to do this for us. I'm going to give a 100 XP bounty. If anyone wants to correctly get the formula, you still get XP if you make a mistake. Anyone want to take a shot at the formula? If I have a squared plus b squared, a sum of squares, very similar to what we did up here, what is the formula to always solve this every single time? I see Gio, kind of, Eva, kind of, Andrea, slightly more confident than other people. Eva, go for it. There it is. 100 XP. Good job. There's your formula. Know it, love it, think about it before you go to bed every night. All right, so let's go ahead and see if we can apply the sum of squares formula to a sum of squares problem. How do I factor 4x squared plus 25? Oh, look, that's a square. This number's even, which means this whole term right here is a square, and this is a square. I have two different squares. I have two different squares. What does this factor into? By the way, x to the power of 8 is a perfect square because that's equal to x to the power of 4 to the power of 2. Anything to the power of 2 is a square. So x to the power of 4 to the power of 2, x to the 8 is a square. So when I'm trying to go from the square to the non-square, I'm really taking this power and dividing by 2. All right, I'm looking for a conjugate pair. Our formula tells us we're looking for a conjugate pair. What is the conjugate pair? Who can help me out? Gio. Okay.
So it's going to be 2x to the third plus 5y times 2x to the third minus 5y.
Like that?
I guess.
Yeah. What do you guys think?
I don't know.
Lots of thumbs up. Don't know, in between. It's correct. That's it.
Good job.
Yeah, so you're really square rooting each of these, right? Square root of 4, square root of x to the power of 6, square root of 25. Square root of x to the power of 6 turns into, square root of x to the power of 6 turns into x to the power of 3. That's where this x to the power of 3 came from. Square root of 4 is 2. Square root of 25 is 5. And then you have to do plus or minus in between there, and you get the conjugate pair. Take the square root of each of these terms, you will get the conjugate pair. Make sure to remember to have that I in there, otherwise it's not a sum of squares. All right, hopefully you're okay with that. Let me see a fist of 5, Chris Hood. Fist of 5, how comfortable are you with factoring that type of sum of squares? 5 is I am ready for a quiz on it. 1 is I just woke up. I see mostly 3s, some 4s, actually mostly 4s, some 3s. I say the average is about 3.5. James, Chris, where are you guys at? Fist of 5. I haven't heard from you guys very much. 2? Is that 2, James? 3, James? And Chris? 3? Okay. So we're going to be doing a harder problem where we will get a sum of squares as one of the factors. So we're going to have multiple steps here. All right. So this example 2 is very, very similar to this problem, this second problem that we did. Because it's a trinomial with something higher degree than 2. So if it's a trinomial, you're always going to use, what was the tool called again?
The Ninja Star.
The Ninja Star. Okay, let's do it. Ninja Star. Don't make it too big because we're going to need some room.
It's gonna get rid of
All right. Quiet raise hand. Who can set up the entire Ninja Star for us? Stego.
Okay, so your top is dose,
Dose.
right? And then your two sides are x,
X.
and then your bottom
3. You made an error. See if you can catch it.
3.
Happens with these guys.
4.
Nope.
So this second.
Yes, it's always this middle term, or this term divided by 2. So x to the second, x to the second. Good job, Stego. You not only get your points for getting it correct, but you get your points for correcting yourself. All right, so 2, what are the factors of 2 that add up to 3? What are they? Quite raised hand. Factors of 2 that add up to 3. James. 2 and 1. Reduce these. They're already reduced. Therefore, we have our factors. We have. And then James, let me give you your XP. That means we have x squared plus 2 times x squared plus 1. One of these is a sum of squares. One of them is not. Which one is the sum of squares? Is it the left one with the 2 or the right one with the 1? What do you guys think? You guys can all shout it out. Left or right? I hear left from James. Which one is a sum of squares? Is 1 a square? Is 2 a square? That's really the question I'm asking.
Right.
Look at your square list up on the wall. About 50-50 so far. Some people saying left, some people saying right.
Oh, right.
We don't know. 1 is a perfect square. 2 is not a perfect square. 2 is nowhere on that list up there. It goes 1, 4, 9, 16, 25. But 1 is a perfect square, which means this thing on the right-hand side is a sum of squares. So if it's a sum of squares, I'm going to take the square root of the first term, square root of the first term, square root of the second term to get what and what? What does this factor into? Square root of 1 is 1, yep. Plus 1, I,
Oh, x plus minus.
x minus 1i, or x minus I. And then we still have our x squared plus 2. Cool. And that is the fully factored form. Go ahead and box it. I will tell you this. Sometimes Khan Academy wants to extend your knowledge further than I would normally want it to. This thing can also be factored using complex numbers. I'm going to show you the additional step that you could do. Square root, and square root. Square root of 2 is gross, but we'll leave it as square root of 2. We can't really do anything with it. This turns into x plus square root of 2i times x minus square root of 2i. It's gross, but it's technically a factored form. And then I write the rest of this, which is x plus I, x minus I. You might discover this one just as a warning, but generally, if it's a free response question in my class, this is the one that I'm looking for. All right, our final example, example 3. Let's do the first step together, and then we'll break out into groups to solve the rest of this. And I have no, okay, I apologize. I see an error already. Can we change the 7 to a 9? Just make a little,
It's not a perfect square.
change it to a 9. All right, what is the first step here? What is the first step? I don't have squares. That's a cube. That's not a square. So this is not a sum of squares. So what do we need to do first to get it into a sum of squares?
Oh.
Yes, go for it.
It was cool.
I can factor out the greatest common factor. What is the greatest common factor? X. There it is. So when I factor out the greatest common factor, this is now x times the quantity of what? That's 9. Now I have the sum of squares. That's a square. That's a square. You guys solve the rest of it. Once you solve the rest of it, we'll come back. But I think it's going to be pretty straightforward. In fact, I'm going to silently do it up on the board in case you want to see what the answer is. Here I go. Once you check your work by looking up on the board, write your summary, and then you may begin on the homework assignment.